All right, so yesterday we saw how to do it with the side and in the apothem. Now I only see the measurement of a side outside and even has radicals. Okay, so what I'm going to do, I'm going to the center of my polygon, it's about here. I'm going to create my triangles here. But now each triangle now, I'm going to cut it in half. Okay, so each of these triangles, I'm going to cut them in half. Okay. Now, if you were to imagine a circle in the center, so let me draw my circle here. If you were to imagine the circle is 360 all the way. So all the way is 360. Now, if you count the little spaces here, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There's 12 of those. Remember, the whole thing combined is 360 divided by 12. Let me erase this. I know 360 divided by 12 is 30, right? So I'm going to say that this side right here is 30 degrees. And this side right here causes a 90. So that means this triangle here is going to be 60 degrees. Okay, 30, 60, 90. Huh. Sounds, rings a bell. That rings a bell. I remembered we covered those. Now, this whole thing right here, it is 22 thirds, and there's a radical 3. 22 over 3, and there's a radical 3. I'm actually going to cut it in half, because if you notice, I'm only using half of it. And then so I'm going to divide it by 2, so I'll put a 2 at the bottom. So that is 22 radical 3 over 6, or better known as 11 radical 3 over 3. Okay. 11 radical 3 over 3. That's the small side of my right triangle. I remembered that if I wanted to know this other side here, I had to multiply. Go back to the 30, 60, 90 rules. The small side to the medium side, you had to multiply by radical 3. Again, if you need to review your 30, 60, 90 triangles, we have those in our notes, previous notes. But if you need to review them, send me a message. We can get together in Zoom. But this is the 30, 60, 90 triangles. And remember, from the small side to the medium side, you multiply by radical 3. So let's see, we have 11 radical 3 over 3, but I have to multiply by radical 3. So that gives me, let's see, 11 times 3 over 3. The 3's cancel out. So this side right here, it is 11. Okay. Now I'm ready to go. I'm good to do what I know as a triangle. Let me focus on this triangle. I'm going to get the area of that triangle alone. It's going to be 11 times, I'm going to write this 11 radical 3 over 3 times 11, and I have to divide this by 2. That is just that triangle alone. Because remember, I multiply the two numbers that make the 90-degree angle and then divide it by 2. So the program that you guys are using, you guys can type in radicals. So I'm just going to go 11 times radical 3 divided by 3. Right, as a matter of fact, you guys can type it all like this. So let me just type it all out. So I have 11 times radical 3 divided by 3 times 11 and then divided by 2. Now this thing gives me 34.92969129. However, I'm going to multiply this. Let me just say it. I'm going to multiply this by something. Okay. How many little triangles do you see there total? Count them. Like, see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I'm going to multiply this by 12. Okay, my calculator gives me 419.156294. Okay. Okay. If your instruction said rounded to 1 decimal place, I'm going to call this 419.2. If it says rounded to 2 decimal places, I'm going to call this 419.16. If it says 3 decimal places, 4 decimal places, whatever it says. All right, let's take a look at number 40. Cool. Let me do the center to my triangle. Center of my polygon, I'm going to go like this. Right, at first I go to the corners. Then I cut each of these in half. Again, imagine, let me count how many of these spaces we have. 1, 2, 3, 4, 5, 6. Imagine a whole circle, 360 divided by 6. So I'm going to say this is 60 degrees. I know this is 90. Or better yet, I'm going to look at it this side. This is 60 degrees. This is 90. And this is 30. So I have a 30, 60, 90 triangle again. I'm going to say this side is 8 radical 6. The whole measurement, 16 radical 6, I divided by 2. Let me show you guys the work in slow motion. 16 divided by 6 divided by 2, it becomes 8 radical 6. Okay. I can figure this side, right? I can figure out the apothem. Now the apothem is the small side of my triangle. So in this case, I'm going to go 8 radical 6 divided by radical 3. That looks like there's an 8. Look at the radicals. If they were just a simple fraction, can you simplify it? Right, 6 over 3, could that simplify? That is radical 2. Right, we can do the long way, 8 radical 6 over radical 3, and I can ask you multiply both sides by radical 3. So we have 8 radical 18th over 3. Radical 18 simplifies to 3 radical 2. So I have 24 radical 2 over 3, which simplifies to 8 radical 2. Okay, so we know this is 8 radical 2. Okay, I'm ready to get this area. I'm going to go 8 square root of 2 times 8 square root of 6 over 2. You can type this. You guys have a calculator now that can type radicals. You can type fractions. So that alone will give me the area of this triangle. Whatever I get, I'm going to multiply this by 6. Let me show you why 6. Let me count how many triangles I have. 1, 2, 3, 4, 5, and 6. That's why I multiply by 6. Okay. So let me go 8 times the square root of 2 times 8 times square root of 6. Everything divided by 2. Then I multiply by 6. According to my calculator, I get 665.1075101. Okay, so if it's one decimal place, 665.1. If it's two decimal places, 665.11. Okay, let's take a look at question number 41. First, here in the centered, I go to the corners of my polygon, right? The corners, we call those vertices. So I go to the corners, and then I cut each of my triangles in half. You're gonna count that there's 12 triangles now, so 360 divided by 12, I'm gonna find out that this right here, it is 30. This is 90 degrees. So it means this is 60. I'm looking at a 30, 60, 90. And I'm gonna say this side right here, it is 4 radical 3. Right? 8 radical 3, I cut it in half. So 4 radical 3. And I'm gonna say this side right here, it is 12. Let me show you guys the slow motion. So 4 radical 3 times radical 3 becomes 4 times 3, which is 12. So I'm gonna say that right there, it is 12. So that triangle, like I said, I'm just focused at this triangle. I'm just focused at that triangle. I'm gonna go 4 radical 3. So 4 times radical 3 times 12 divided by 2. And whatever I get, I'm gonna multiply this by 12. You can count the triangles. There's 12 of them. All right, so let me go 4 times the square root of 3 times 12, all divided by 2, press equal, times 12. My calculator gives me 498.8306,326. And then look on your instructions, how many decimal places. If it's one decimal place, 498.8. Two decimal places, 498.83. I don't know. Look at your instructions and answer accordingly. Lastly, let's take a look at number 42. I'm going to look at one triangle. So first, from the centered to the corners, right? The vertices. I'm creating triangles. And then I cut each triangle in half. Boom, there you go. We know, I'm going to pick a side. I'm going to pick this side right here. We know the whole thing is 10 radical 3. So the half of it will be 5 radical 3. All right, let me erase this. So I just know that's 5 radical 3. I know this right here, it is 30 degrees. If you count, there's 12 of those, like in the center, right? 1, 2, 3. If you count all those, there's 12 angles. 360 divided by 12 is 30. This is 90, and this is 60. I have a 30, 60, 90 triangle. Again, you should remember how to do 30, 60, 90 triangles. This is 5 radical 3. This is 15. Again, you should know how to do right triangles now. This right triangles. Okay, so I'm gonna go 15 times 5 radical 3 over 2. And whatever I get, I'm gonna multiply this by 12. If you count your triangles, 6, 7, 8, 9, 10, 11, and 12. There's 12 triangles. That's why I multiply this by 12. So let's see. 15 times 5 square root of 3 over 2. So I get my triangles and then times 12. My calculator gives me 779.4228634. And obviously round it up to as many spaces as the decimal. If it's one decimal place, 779.4. If it's two decimal places, 779.42. Okay.